Hi everyone, we are finally on section 3 of types of chemical reactions, and this time we are going to be taking our single replacement reactions one step further and making them double replacement reactions. Now in double replacement reactions, we are going to essentially switch partners of the chemicals that are involved. So the positive ions, remember how we can break apart every compound that is ionic into the positive and the negative, and we're going to switch our positive partners. So whenever you have something like mixing an aqueous solution of potassium iodine, which is over here on the left, it is a clear liquid, with lead to nitrate, which is the other clear liquid that's in the beaker here, you're going to get a precipitate. The reason for that is whenever you pour these two reactants together, you'll get two different products. One of them is going to be a solid and the other one is still going to be in solution. This is just like the ornament lab that we did before break. Remember, we put two things that were clear, and when we shook them together, we were able to get the silver to come out of solution and coat the inside of that ornament. So let's take a look at this double replacement reaction. So double replacement reactions are going to exchange the positive ions between the two compounds. Remember, positive ions are always first. They're always the first thing that is listed in our chemical equation. So just by looking at the top reaction here, we have the first thing listed here is the K. This is our positive ion here. And you then have lead, which is our other positive ion. Remember, those can also be called cations. So a double replacement reaction, or sometimes I'll say double displacement, they're both the same. They're going to exchange those two positive partners. So the potassium is going to go where the lead is currently, and the lead is going to switch places and go where the potassium originally is. And you can look over here, you have your lead iodide as well as the potassium nitrate. So you can see how they have switched partners and you get that double replacement reaction. Typically they have to be in solution, so it has to be aqueous. Remember, that just means that it is dissolved in water. And they're going to produce something that is either solid, which that is our precipitate, a gas, so you'll see bubbles, or something that is a molecular compound, just like water, which is a liquid. So we're going from things that are both aqueous to something that is aqueous, and this guy's actually solid. So the way that you figure this out is on the chart on the next page, but before we get there, our general format for these reactions would look something like this. On the bottom we have AB plus CD gives you a D plus CB. Now the one thing to note is that your positive is always going to be listed first, and then your negative partners will end up switching. And if you ever wonder where these subscripts come from, up here at the top, you can see that one right there. Those are from your cross drop down rules. So our cross drop down rules come from our ionic compounds. That was back in chapter 7, so if you want to look back, you're more than welcome to do so. Now let's figure out how we get our solid guys. So there's a cool a solubility chart called a solubility table. This is always going to be given to you. You will never need to memorize it. But to figure out if something is solid or a liquid or not possible, you have this cool chart. So if it has SOL in green, that means soluble, meaning that is going to be aqueous still. If you have something that is insoluble, this is going to turn it into a solid. And then slightly soluble, that means it can be aqueous or a little bit solid. Now, if it is blank, that means something doesn't exist. So if you start to see something that doesn't exist, make sure you ask, especially if it's on a test. So let's take the two products from the last slide. You have PbI2 and KNO3. All right, so at the top you have your positives, and on the sides you have your negatives. So remember, our positives are listed first and the negative is second. So go ahead and find Pb on our chart, circle it. I like to do that, it helps me find the right spot. And then you would find your negative, which is your iodine, and then you go until the two boxes meet. And hey, look at that. It says it's insoluble. If you look back on the last slide, it is also insoluble. It says it's a solid. So we confirmed that one. Let's take a look at our second one. So we have our positive and once again our negative. So once again, I'm going to circle my potassium and circle my nitrate. Follow the boxes until they meet. And it says that it is soluble, meaning it is aqueous, just like we found on the last slide. So for every double replacement reaction, one of the following is usually true. One of the products is probably going to form some sort of precipitate or is slightly soluble, meaning that you're going to see something solid. One of the products can be a gas. So if you don't see a solid, you might see bubbles. And you will also potentially see something that is a liquid, like the molecular compound of water. So those are the three, one of the three is going to always be true for that equation. So whenever we're writing a double displacement reaction, you want to figure out what's our positive, what is our negative, and then switch the positive partners. So remember, our positives are always going to be first. So I like to break them apart into their positive and negative ions first. To do that, we're going to grab our subscripts and bring them up. And since this is a polyatomic ion, that means there's a 1 out there. We're going to grab that guy, pull it up as well, to get K plus and CO3 2 minus. And that is going to be added to, once again, we're going to reverse pull up to find our numbers. Pull that 2 up from chlorine and the imaginary 1 up from barium. So we would get Ba2 plus as our first ion and Cl minus as our second ion. Now remember, we're going to switch our positive partners. So the potassium's going to go over here with the chlorine and the barium's going to go where the potassium is. And that's going to give us the following. That we have switched our positive partners, we're going to grab those charges like we did back in chapter 7 and cross drop down. So remember, that cross drop down allows us to cancel out those charges and make sure that everything is balanced in our equation. We have now cross drop down our charges. And one last thing, remember, we can also reduce these guys right here. Because they're both 2's, we can divide by 2 because it's an ionic equation. And so our final answer would look like the following: barium carbonate and potassium chloride. So after you have done that, you want to make sure that you balance your equation. So if I like to rewrite our original equation now with our new products, and then you balance just like we did in the last chapter. Alrighty, so I have rewritten our products with our new reactants, and then you would want to make sure that you make your chart to balance out this equation. This is not something new, so I'll let you do this part on your own, but after you make that chart, your coefficients should look something like this. You should just have that 2 in front of your potassium chloride. Everything else should be balanced, meaning that there is the same number of each of our elements on the product and the reactant side, and you are all set. This is also taken and drawn out for you in your notes if you would like to have them a little bit neater. But that is it for today. That is our double replacement reactions.